Who's now? Okay. All right, so it's already started recording. Good morning, guys. We'll just very quickly go through the test paper. So I will share the PDF later, but it's important to know what we are looking for as we go through this particular test paper. This paper is marked out of 42. So onto that, you convert it to percentage. Only 60% and above is a credit. So as you know, when you talk about credit or level, they talk about 60% and above. Anything below 60% is not a credit. They don't count to go to IBTE. They don't count to go to anywhere at all, because anything below 60% is not a credit. Anything but a credit, you cannot do anything afterwards. Okay. So in this first set of questions, we are looking at physical changes. Physical changes usually refer to changing states of matter. So states of matter were your lower secondary science. So we're talking about solid going to liquid, liquid going to gas, gas going to liquid, liquid going back to solid. All of those are physical changes. So we see melting here. So there's solid going to liquid. We see boiling there, which is liquid going to gas there. So, you know, those two are our only physical changes. Pretty straightforward there. Question number 2 is about formula. Again, another year 9 topic. Aluminium sulfate, they are very generous. They give you the formula there. So your job really is how to make it happen. We talk about labeling. Valency is the charge of the ion. The charge of the ion is 3+, so the valency is 3. The charge of this sulfate is 2-, so the valency is 2. And then we label how many, so that we do the crisscrossing or the cross multiply. So 2 there means 2 of the Al3+. So I have Al3+, Al3+, and then I get 3 SO4 2-. These were straight from year 9 chemistry. So 2 of the aluminium and 3 of the sulfate, just like that. That should be option A or B. C and D are wrong. You do the exact same thing with Na+ and PO4 3-. The charges 1 and 3 respectively. So 1 and 3 is the valency. And then you can do the cross multiply, something you would have done on your own paper, because I've shown you how to do it. If all this while you are just been copying will not get you anywhere, because they don't teach you how to think in the actual setting when you don't have someone to help you at all. The next thing is about rate of reaction. In this second reaction, you do it at a different temperature and the rate increases. Something called the Cambridge syllabus. Cambridge inform you in advance. So we inform the students in advance when we go through topic by topic, like your rate of reaction topic. That was a couple of weeks ago. So straight from the notes, the note itself always started out from candidates should be able to. These are called the syllabus or the learning objective. If you are not able to describe the effect, you are not a ready candidate. And by the time we finish the topic, we did the work, we corrected the work, we did real work, and we did real corrections, and you did real revisions. Then when you sit for the actual face-to-face exam without online and stuff, then you will know if you are able to or not. We know that just describing the effect, as the concentration decreases, rate decreases. When you increase concentration, rate will increase. Surface area increase, rate increase. Temperature increase, rate increase. Temperature decrease, rate decrease. When you use a catalyst, rate will increase. It becomes faster with a catalyst. But a catalyst is not used up because it is not a reactant. It speeds up the reaction. It is unchanged at the end of reaction. Explain that a catalyst is unchanged at the end of a reaction. Well, we will come back to this later on, because this is just a review of your syllabus, since you have done the syllabus itself. This second reaction, the rate increases, so that means it's faster. So they must collide more often. Collide more often is definitely correct. If they meet each other more often, they collide more frequently. There's another word, collide more frequently. Frequent means more often. So we can cross out less often. And then we are thinking about faster reactions, so must be higher temperature. Without further ado, you know that B is definitely the correct answer and not D there, because D is lower temperature. Now, part 4, this is in the redox topic. As you know, this is a reducing agent. Reducing agent, what happened to itself? Well, reducing agent causes the other substance to be reduced. It reduces the other one. It reduces the other substance. But what happened to itself? If the other substance is undergoing reduction, as the partner, you yourself must become oxidized. If you get oxidized, that means reducing agent will gain oxygen. So we're looking at carbon dioxide gaining oxygen. We don't look at the number in front. We look at 1 unit, just like when we did MR calculation, we look at 1 unit. So the CO gains oxygen to become CO2. So we know that CO is the one that undergo oxidation, and therefore it causes the other substance to be reduced. This substance is now losing oxygen, and therefore you get reduced to form iron. But this substance itself, it reduces the other one, itself get oxidized. Now between these two, some people thought the answer they will be gaining mass, but then we need to be very careful. Gaining mass is correct. It is indeed gaining mass, but the explanation for oxidizing or reducing agent is in terms of gaining and losing oxygen. So this is the correct definition. You need to define correctly, and you are not just looking for a correct fact. This is a correct fact, okay? But this is the correct explanation for oxidation and reduction. This one, it steals the oxygen. It gets the oxygen from the iron 3 oxide, and then it becomes CO2 then. The next thing is about concentration. When you add water to syrup solution, your syrup becomes less sweet because it's become less concentrated. Here, you have some dilute hydrochloric acid. When you add water to the hydrochloric acid, it further dilutes the acid. Dilutes the acid means it makes it less concentrated. When you add more water, you become less concentrated. As the concentration of solution decreases, rate of reaction would also decrease as well. Number 6, a lot of people chose this answer A here, which is definitely wrong, because even lower secondary science students will have told you that the air that we are breathing in has about 78% nitrogen. That was straight from environmental chemistry topic. So A is definitely wrong. Methane is produced from vegetation, decay of vegetation matter, as well as livestock farming. Incomplete combustion of fossil fuels give you carbon monoxide. This one is straight from environmental chemistry. Very, very recent topic, which unfortunately some people didn't do the work, and therefore they don't understand what is going on at all. So where was it? Environmental chemistry. So these were the very last lesson we did 2 weeks ago. 2 weeks ago. So there was carbon monoxide from incomplete combustion of carbon-containing fuel. Methane is vegetation decomposition, and waste gases from animals' digestion. Let's go back to the actual thing here. So that thing is definitely wrong. It should be CO, which is carbon monoxide. Then noble gases make up about 5%. That is definitely wrong. It's less than 1%. So less than 1% of carbon dioxide as well as noble gases. So 3 things are wrong. There can only be 1 correct answer there. It's all about elimination and reading the question. Global warming, if you go back to the table as well as work 2 on environmental chemistry, there are 2 gases that contribute to global warming, carbon dioxide and methane. Those are the dangers associated with global warming. Dangers associated with these 2 gases will be global warming. Now, this next question is about complete the diagram. Some people just write down some words and expect to get the marks. You don't draw anything to complete the diagram, you don't get anything at all. You draw this bit, without drawing this bit, you don't get anything at all. 2 choices, whether you draw this or this, not both of them. This or this, both of them can collect gas, but this is called a gas syringe. This is called a measuring cylinder. You collect over water, not very good because carbon dioxide. This is a carbonate, metal carbonate plus acid. This is straight from general equations. So metal carbonate plus acid will give you metal salt. You have hydrochloric acid, you will get a chloride salt. You get carbon dioxide, you get water as well. General equation, year 9 chemistry. carbonated drink, Pepsi, cola, carbon dioxide can dissolve in water. This is the better method than this, but this is acceptable as well. The test for carbon dioxide, I remember I can show you guys again when I share the message that I asked you guys to copy down the test for these three gases. You also saw me demonstrating the test for each and every one of these. The carbon dioxide, you use lime water, make sure you can spell it. So that is basically calcium hydroxide. And then when you plus carbon dioxide, you get calcium carbonate. But what do you see? You don't see the calcium carbonate. You see the lime water turning milky or cloudy, or you get a white solid forming. Okay, so make sure you know the test for each and every one of the gases. Now, this is the exact same reaction, metal carbonate plus acid, you will get metal salt, carbon dioxide, and water. I don't know why some people put down hydrogen or oxygen. That means they don't even have the basic year 9 chemistry content. The simplest thing you can think about is year 9, but when you cannot do year 9, you cannot expect to do year 10 and year 11. Okay, so here, this is not collecting gas. You're allowing the gas to escape. You're using a thermometer to measure temperature changes. So what is this type of reaction? To indicate the temperature has increased, this word, exothermic, comes under this topic. The second topic we did in year 10, that was called energetics. And in the energetics topic, there are 4 things in the syllabus. Cambridge say candidate should be able to, and I make sure just last time when I first taught this topic, I made sure I use this term again and again. I made sure that all of you saw the experiments face to face. You saw it, you observe it, you saw it with your own eyes. That the temperature of the solution increases because the reaction releases heat, and there was an example of neutralization between an acid and a base, and that causes an increase in temperature because there is an exothermic reaction. Combustion, when I burn something in oxygen, there's exothermic reaction as well. On the other hand, just because the question paper doesn't ask you an endothermic reaction, you're supposed to know what happened in endothermic reactions. The reaction, the solution will get colder when there's a decrease in temperature. Some of you actually saw it. In fact, I think most of you actually saw it with your own eyes when we were doing the lesson itself face to face, and you just have to really, go through your syllabus again and again. Now, this reaction involved the production of gases. So you saw gases, but you don't see the colorless gas. You can never see colorless carbon dioxide. What you see is bubbles. So the reaction has stopped when there are no more bubbles. Some of you decided to use the temperature. You say you don't see any further increase in the temperature. That is acceptable. But the easiest one is, of course, just looking at the bubbles. No more bubbles get produced. No more bubbles are seen because you cannot write no more gas are produced because you cannot see the gas. The gas is colorless. You can only see the bubbles. When there are no more bubbles, it means no more gases. This next one was very badly done. Year 9 chemistry content. But it's also a primary school. How do you separate sand from water? You do this thing called filtration. The Malay word is called tapis. But of course, some people, they just don't even know separation techniques at all. When we add water to the solution, we are decreasing concentrations. And as such, the rate will decrease. Describe the effect for 1 mark. Straight to the point, answer the question, what happened to the rate? Other factors that affect the rate of reaction, I talked about it just now when I showed you the syllabus. There can be temperature, there can be surface area of the solid carbonate, fine powder versus the lumpy big form. But what you cannot say is you cannot say catalyst because this reaction doesn't have any catalyst in there at all to begin with. Okay, hopefully that makes sense there. You can choose either one, but temperature is the easiest thing to just change the rate of reaction. The next question is not about carbon dioxide. So I don't know why people cannot even read as a year 10 student. And these are the normal year 10 stream, and the normal classes already cannot read. So you can imagine the applied stream students, whether they can read or not, is another question. This is called H2O2. There are 2 of them. They give you water and they give you oxygen gas. There are about 21% oxygen gas in the air you're breathing in. You allow the gas to escape. You see bubbles, you allow the gas to escape. And when you do that, your mass will decrease because the gas escapes. You are losing masses. The gas escape, you will get a decrease in mass. Why is it the mass decreasing? Because the reaction produces the gas will escape in those reactions there. Okay, and of course, once you add in the MnO2, it will speed up the reactions, and that is why the gas produces that's why the decrease in masses is observed in a shorter period of time compared to this first one. Too long to measure. You can't measure the time. It takes too long. Okay, so you produce a gas. Oxygen is a gas. You lose the mass. You get a decrease in the mass. Balance reading. Now, this thing I have marked incorrectly. So please make sure that the work that I've marked, and you can give us a free mark. I'll check back everyone's work later on and add the mark accordingly. It says, what effect does the mass of manganese dioxide? Focus on the mass and the rate. Now we look at the table. As the mass of the manganese dioxide increases, as the mass of manganese dioxide increases, the time taken for the reaction to finish decreases. It takes shorter time for the reaction to finish as this mass of manganese dioxide increases because the reaction is getting faster. So the rate increases as the mass of manganese dioxide decreases. Don't forget, this is time, this is not rate. If it takes shorter time, the rate is faster. So it should be as the mass of manganese dioxide increases, the rate increases. You will get 1 mark there. Okay. Now, next thing, use the information in the table to explain the role of manganese dioxide. I put out 3 things here, but I just realized that you don't get the final mark unless you use some information from the table. You need to mention something about the catalyst is not used up at all, because as I mentioned in the Cambridge syllabus, catalyst is not used up at all. You can see catalyst is not used up at all. What you put in is what you get out at the end. The mass doesn't change because catalyst is not used up. Number 1, that's how you know it's a catalyst. When you use it, the rate of reaction is faster because the time taken for the reaction to finish gets shorter. That is why it is speeding up the reaction. It makes the reaction go faster. It is a catalyst that is speeding up the reaction. Make sure you use some data in the table. Talk about shorter time, lesser time for the reaction to finish when you use more and more of the catalyst there. But the catalyst is not used up. So do not just state, but use some information from the table. I just show you that it wasn't used up. I have just shown you that the reaction go faster as it takes lesser time for the reaction to finish. Now the next question is about oxidation and reduction. Identify. So which one get oxidized, which one get reduced? Why? So most of you don't get the full mark because you did not answer everything in the questions. Again, can year 10 normal student read? If year 10 normal student cannot read, then year 10 applied student would have even greater problem as a year 10. Next year doing all level. Okay. Magnesium, going to magnesium oxide. Magnesium has gained oxygen. Magnesium get oxidized. 1 mark together. You don't get half a mark. There's no such thing as 0.5 marks in Cambridge exam. Never. You can read the Cambridge website. They only get 1 or 0, just like that. Okay, so CO2 loses the oxygen and you become carbon. Loss of oxygen is reduction there. Calculating MR, there are some people who cheated in this exam. They use the internet when they are given the information here, the relative atomic mass. They don't even need the periodic table, but some people decided to cheat because they just cannot stand not cheating at all. They cannot stand at all. Okay, so carbon dioxide from the equation CO2, there are 1 carbon and 2 oxygen, should be all right there using this value here. Magnesium oxide is the biggest problem because they look at 2 MgO. What does 2 MgO actually mean? 2 MgO from your notes in year 9, it means there are MgO and MgO. However, there was also the notes in year 9, relative molecular mass, MR, is for 1, only for 1. Satu buting sahaja. You don't look at 2 of them, you look at 1. Therefore, it's just 24 for 1 magnesium and 16 for 1 oxygen, add them up together. I might have marked you incorrectly for this, so make sure you check 22 and 40 for your answer so that you get the correct one and let me know if I marked incorrectly. This is called reacting masses. How much react is not just 1 unit. MR is for 1 unit. That was year 9 HBL. And of course, now that you're in year 10, you can do year 9 stuff. You had the whole December, the whole January, February, and March to catch up to year 9. And we will never come back to this again. Never, ever. Okay? But the questions will be asked again and again. So 24 is for 1 magnesium, and there are 2 of them. So that's 48 grams. This is now masses. This is MR for 1 unit. This is depending on the equations because we are going to do ratio. So 2 times 24 for the magnesium, 1 times 44 for the 1 carbon dioxide. The question asks you 24 grams, not 48 grams. So this is X. You can see this is half. So this is half. It becomes 22 grams if you do the math correctly. Same thing for that. If you do the math correctly, you get 40 grams of magnesium oxide because 2 mg giving you 2 mg all there. Now the next question, this is about heat loss. So this question results in a magnesium and hydrochloric acid is an exothermic reaction. That's why there's highest temperature because temperature increases. That's how you know that this reaction releases heat energy. And the biggest experimental error is due to heat loss. Why is it not accurate? Why don't you get what you expect to get? Because there's heat loss to the surrounding, number 1 factor. Same thing in physics. You will probably be asked this question in the physics setting as well. Heat loss will result in less accurate result. So what do? When you are cold, you will cover yourself with blanket, you will wear jacket, you will wear hoodies, and therefore you want to prevent the heat from being lost. You cover this with a plastic lid. So use it a lid, and then you can insulate the beaker. You can insulate or cover the beaker with like a insulation layer, something like cotton wool or something. But you can also use a plastic cup. That was how I did the reaction last time in the class. I use a plastic cup because plastic is a poor conductor. It's an insulator. So plastic cup will help you to prevent the energy, the heat energy from being lost easily. So these are the improvements to the experiment to prevent heat loss there. The next bit is about reading thermometer. Most of you are okay with this. Some people skip this question. I have no idea why. It's supposed to be the easiest bit in the whole paper. You do not want to lose easy marks, but at the same time, you want to be able to do the whole paper. How do you tell the reaction is exothermic? As I've shown you in the notes, I'm going to show you again because some people, even in year 10, they don't know. They don't know what they have been given because they never revised. Candidates should be able to. Exothermic reactions result in a higher temperature because temperature of the solution increases. It becomes hotter. Now, the question really is asking you what data from the table? What data from the table? So you cannot say release energy because the data in the table doesn't show you energy. It shows you temperature. There is a temperature rise for each and every one. It gets hotter. This last question is about decomposition of metal nitrate. You don't learn it as a syllabus, but you learn rate of reaction. So this question is about rate of reaction. Relighting glowing splint, that is oxygen. Lime water turns milky, that is for carbon dioxide. And then the burning or the lighted splint, the one with the fire, burning or lighted splint, burn with a pop sound, that is hydrogen gas. So these questions here, control the amount of heat. You want to keep it constant. There is this concept called fair test. I remember reading it in primary school science textbook, Also in lower secondary science curriculum, you have learned about fair test. You must keep some stuff constant. Constant means keep it the same. Why? Because we are changing. We are changing that. If we change the metal nitrate, we must keep everything else constant. We must keep the heat constant. How do we do that? Keep the heat constant. People talk about the metal nitrate, people talk about the fire, the glowing splint, but you are mentioning about the heat. So something about use the same setting. So you don't turn off the Bunsen burner, you just keep it on. You use the exact same Bunsen burner, the exact same fire setting. So you don't change it, you don't change the oxygen, you don't open the air hole or close the air hole, you just keep it. And then you hit it at a fixed distance. You don't change the distance. You don't just hit it here and then suddenly you hit it above here. No, you want to maintain the same heat. So hit at the same position, hit at the same distance. So you can say position or distance is the same thing. All right, hopefully that makes sense to you. The next bit was very badly done. People talk about apparatus and stuff. That means they don't even know primary school science. Very sad, yeah, very sad for a year 10 student. Involving metal nitrate. Something only involve the metal nitrate. It must be the mass or the amount. How much you use, you must keep it the same because we are simply changing the different metal nitrate here. That was the follow-up to these questions. Averaging was very, very badly done. Very, very badly done, okay? Averaging. Here, if you have 3 readings, usually you would do 100 plus 150 plus 100, and then you remember to divide by 3, like that, because there's averaging. 3 results, so add them up, divide by 3, that's averaging. Average should be close to your value. But this question said, do not use anomalous. Anomalous means not ordinary, out of ordinary, special. Do not include something which is odd. Something odd, something doesn't make sense. This is 100 and 100. 150 doesn't make sense. 300 and 320, they are close together. This is very far away. 400 and 410, very close together. This is further away. These two are quite close together. This is very far away. Only because the question said do not. They bolded it, but some people, they just don't even read the question at all. So instead of doing that, you should have done 100 plus 100, then you involve 2 readings. If you have 2 readings, you simply divide it by 2, you get 100 divided by 2, 200 divided by 2 on your calculator. You're allowed calculator in exam. If you didn't use the calculator, something was wrong with you, okay? Now I get 100, I get 310, 405, and 200. As you could see, going down to group 1 is actually lithium, sodium, potassium, rubidium, okay? But they mix up the order there. So which one is the fastest? Fastest means the easiest to decompose or the greatest rate. It will take the shortest time. Fastest means the shortest time. You cannot talk about fastest being the fastest time. There's no such thing. Time only is short or long. We talk about fastest, so we want the shortest time. It's the easiest to get the oxygen there because it's the easiest, it's the shortest time for the glowing spleen to relight. So it's the easiest to produce the oxygen gas because it's the fastest to produce the oxygen gas. It takes the shortest time to produce the oxygen gas. That is the fastest one to decompose. Just like that, you get 2 marks there. That's it really for this test paper. So if you got any questions, feel free to text me directly. So I have marked your MnO2 question incorrectly. So make sure you check your work and let me know if there are changes to your marks or anything. So do submit the corrections letters tomorrow. But please, do whatever you can today rather than wait until tomorrow. Okay, thank you everyone. The recorded session will be shared later on. I'll share the PDF with you on the group chat later on. Okay, thank you. Bye-bye.